Thank you so much, Chitra ma'am and Karthik ma'am, for the introductions. Good morning to everyone here. And I'd also like to thank the ACM and the CSWG, the Department of Information Technology, SSN College, SNU, for giving me this opportunity to come back to the place that matters to me, which is my university, my department. Right? 5-6 years ago, I was exactly where you guys are sitting, seeing someone else talk about security and all the other topics. So, before I start, do you have any questions? Any questions about my profile, presentation, etc.? Also, don't hesitate to ask questions. I'm not 30, 35. I'm one of you guys. So feel free to ask any questions. Anything. So how many of you are second year? What? Completed second year. So second year with part. Third year? What is this grouping? Second year, third year. 5 years? No 5 years? First year? You guys are behind. You are from masters. Okay. So, how many of you have heard of DevOps or DevSecOps? Any ideas? What is DevOps? You can give a wrong answer. It's fine. It's not a 2-mark question or a 60-mark question. You have to be like, what is DevOps? Any idea about what is DevOps? What is DevSecOps? What is IT operations? Any idea? All right. So, I'll just dive right into it. Presentation. So, first up will be the topic. What is the introduction to DevOps? So, basically, this term that you've been hearing so far, what exactly is it? Like, what is the hype behind it? Then we'll cover writing and executing some scripts on Linux terminals, basic scripts like ls, pwd, etc., etc. Just on a Linux terminal. Next up, we'll see whatever you achieve using the Linux terminal, you can achieve the exact same thing in your DevOps pipeline. So the difference is that instead of doing it inside a terminal, there is a separate laptop or a separate computer where the computer's only job is to run that script which you've run on your terminal. That's the only difference between the 2 and 3, right? And next up, we'll see security scans using Linux terminals. So like how I'm trying to take this is, whatever you achieve in your Linux terminal, you can achieve using a DevOps pipeline. I'm trying to show that your understanding of Linux terminal is equal to your understanding of DevOps pipeline, right? So now what we'll do is we'll run some security scans on certain applications, like you might have heard of like VAPT, vulnerability assessment and penetration testing. So during VAPT, we use a lot of tools to run the security scans, and then it will give you security vulnerabilities. These vulnerabilities, you will be able to visualize it in your Linux terminal. And the next, as you can see, the same thing will be like achieving it using a DevOps pipeline. And last but not the least, this is the basics. Like 1 to 5 is the basics. I'm going to skip ahead everything in between and directly take you to what an enterprise grade DevSecOps pipeline would look like. For example, if you're used to writing like linked lists or something, we're going to skip that and directly go to a lead code hard question, just for example, right? So this is covered. I'll just blah 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 blah. So I'm from 2016 to 2020 from this college. I have about 4 years of experience in information security, penetration testing, DevSecOps, risk assessment and mitigation, and security like architecture and all that. I also have a certification which is CDP, Certified DevSecOps Professional, and this is my whole skill set. So like regarding AWS, I know the entire security stuff and just some other stuff. So introduction to DevOps. So basically, so let me give you a brief history of how DevOps came to be, right? So like initially there were 2 teams. There's a development team and there's an IT operations team. The goal of the development team or the goal of the software engineers is to make sure that whatever the product team asks you to build, you build it. Let me take an example. You have idli, right? Most of you may not like idli, but you have idli. So the software development team's goal is to make sure that when you have the ingredients for the idli, you make the idli. That's their goal, right? So the product team will tell make the idli, software development team will make the idli, right? The same like analogy, if you take it from a software perspective, the product team will be like, hey, I need you to build a feature which can count the number of email addresses. That's the goal of the product team, product managers, as you might call it. And now the goal of the software team is to build that feature using any application they want. They can use Java, they can use Python, .NET, like anything you want, right? Like any tech stack which the CTO has decided, Chief Technology Officer, will use that to build the application. Now, what DevOps does? No, before that, I'll say what is the shortcoming in this. Can you guys guess what are the problems in the approach I currently told? Development separate, operations separate, product managers separate. Okay, I'll give one clue. So after you develop an application, you have to deploy it somewhere. Right? If you eat the idli, only then it's useful. So basically, the operations team, what their job is, whatever the software team builds, they'll take that and deploy it on an on-premise server. It should look something like this. You can consider this an on-premise server. So right now you're seeing the boom of cloud and EC2 instances and all that. Previously, all of this never existed. It was just on-prem. So there'll be a room cooled with nitrogen, a liquid nitrogen, and you'll have a huge server rack. Thousands of servers, hundreds of servers, 10, 20, 30 servers, depending on the application and the company. And what used to happen is, whatever is the software you build, the operations team will take that software, deploy it on that server, and then they'll open port 80, port 443 on that server to the outside world. That is how internet was built. That is how we used to visit all the websites we know. Your google.com previously was not hosted on the cloud. It was hosted on a huge rack of servers just like this. So this is just one server. Like this, there were thousands of servers probably, right? Now can you tell me what's the problem with this entire thing? Development, operations, product managers, any guesses? What could go wrong? The software is broken. Exactly, that is one point. Anything else? The building of the software is broken because there are multiple teams. Miscommunication could happen, and things go wrong. Any other guesses? Whose idea? Yeah, something like that. So essentially what she's trying to say is that the development team will be like, hey, you need to deploy this as fast as possible. Operations team will say, hey, the server went down. I can't deploy. There's no liquid nitrogen. There's no power. We are running on backup electricity. Yada, yada. There's a whole lot of issues. The solution to this is DevOps. So what basically a DevOps does is it merges development and the operations team together into one team called the DevOps team. So here what happens is the dev team are responsible for the planning. So first stage, so you might have heard of the waterfall model, right? How software is built. If you paid attention during your software architecture class. So essentially how like the waterfall model works is you design this, you get the requirements phase, then you plan, you design, code, test, deploy. This is the waterfall model, top-down approach, right? The problem with the waterfall model is if you're in the third phase, which is probably, let's say you're in the coding phase, and the client comes and tells you that, hey, we have to make a change to the software. You're going to have to go all the way back, redesign your software, recode your software, and then go forward with testing. This costs time. And in the software engineering industry, time is everything because the faster you go to market, the faster your solution is out in the world. The faster your solution is out in the world, the faster you earn the money, right? So essentially what the DevOps will do is your entire cycle, your entire waterfall model will become a cycle like this, right? So first you plan. Now this planning involves a product managers, whether you like them or not. I personally don't like them, but don't tell anyone I said that. So the product managers are involved in this phase, PMs, right? So they will tell you what sort of features do you have to build for the software, what sort of requirements are there, what exactly are you going to build. That's what they'll tell you in the plan phase. After the plan phase, you have after you know what you're going to build, you basically start to create it, which is through any software that you want. You can use Python, you can use Java, .NET, any software tech stack that you want, you can use to create the vision which the product management team has built for you. After creating, you verify if it works, then you package it up. So now, like the development team's job ends over here. This is where the development team's job ends. Next, what happens is this entire phase that you see next is going to be the operations team. But right now, I've told you that the development and operations team are merged, right? So what happens here is there is a separate like engineer called a DevOps engineer. The job of this DevOps engineer is to take care of everything in this entire cycle that you see, all the way from here to here. Everything is taken care of by the DevOps engineer. So what do you mean by a package here, right? So let me explain it in this way. Every day, you have to eat 2 idlis, right? What you're going to do is you're going to go to a shop, buy 2 idlis, take it in your hand, and then go to your office, eat. Is that a good way to do it, or is it better to pack the idlis and then go with you in one package? That's better, right? Essentially, this is what you're going to do for software. In software, what you're going to do is every software has certain dependencies, certain parameters, or certain environment which it requires for it to be like, executed properly. For example, in Python, if you use import matplotlib and your environment does not have the library matplotlib, it won't run because the dependency of that code is matplotlib and matplotlib is not there in your code, right? Similarly, in DevOps, the main problem which like the developers will feel is each developer will have their own machine and no two machines are the same, right? So for example, in this, if I install Python and in my MacBook, if I install Python, there are things that are going to vary. The version of Python, the Python compiler, many things will change. While I'm writing the same code, why is the environment that I'm deploying the code in different? It makes no sense, right? Which is why we have something called Docker or like Hashicorn or the other examples of Docker, right? Through which you can containerize the environment within which your software is being built. So essentially what this is going to do is in every single machine that you want to deploy the software, it's going to be the exact same machine. It's going to be exactly this laptop cloned to 2000, 3000 times, as many times as you want. That's what a Docker will do for you. This is an important introduction in DevOps because previously, remember I said there were servers. You have to make sure that each server that you have has the same exact packages, same exact versions of the software, versions of the dependencies, etc. Here you don't have to do that. All you need to do is open up a container and say that, hey, Python version 3.2, its dependency version 1.x, etc., etc., etc. Now what you can do is you can just clone this container as many times as you want. And you can deploy this container anywhere you want. It's going to be exactly the same. And hence, the operations team job of making sure everything is the same goes to zero. They basically just have to make sure that this container is done very much properly. Right? After you package, you basically release it to the world. Basically, you take the package, deploy it on the server. I'm not talking about this server here. I'm talking about AWS or Azure or Oracle Cloud or Google Cloud, right? There are multiple other players, but these are the most popular ones. So what these cloud providers will do is, instead of you like hosting the huge server, they themselves will do the hosting. And they'll do it underground, they'll do it in submarines, so what you might have probably read in the news, they have thousands of servers built underground. So why they build it underground is because of the cooling. So these servers release extremely large amounts of heat, which is why you need the liquid like nitrogen to cool it, which is a bit of a costly thing to do, right? So what they do is they make use of the cool temperatures under the ocean, and they just build all these servers into a huge rack. They like put it inside the box and they push it under the ocean. So the ocean takes care of the heat, right? Because it's very cool down there. So that's what these guys do. And sometimes they'll also keep it in remote locations where it's very freezing, like Antarctica, like right? So that's about packaging and releasing. After like releasing it, the next job is you have to configure certain monitoring tools which have to be in place. For example, let's say your software is there, everything is going good, and suddenly it crashes. You'll have no idea of why the software has crashed or what led to the software like crashing, right? Which is why there are certain tools like Datadog or you have Splunk. So what these tools will do is every request that hits the server and comes back as a response, it will log it. There will be an entry in the database that says, hey, this is the request, this is the response. And this will be logged in a tool called Splunk. which is then connected to a database from AWS itself. Let's take an example of AWS itself, right? Let's remove like everything else. So in AWS, there's RDS, which is relational database systems, your SQL basically, right? So these logs will then go and sit in RDS. So how this is going to help a DevOps engineer is if something goes wrong in the package, if there's something wrong in this container or something wrong anywhere in the system of deployment, that Splunk I told you about, Splunk or Datadog will catch this in a log, and each log will have a different like error code. For example, 200 is the error code for OK. OK means the request is OK, the response is OK. 402 not found is there. Then you have error 533, which is for like rate limiting, etc. There are a lot of error codes that are there. It depends. It differs. So what I have done is, for example, let's say you are doing rate limiting. Like, do you know how rate limiting works? Rate limiting is basically where a server, you are going to restrict it to serve only 10 requests per second. So if you want to talk to me and this entire audience is talking to me, can I talk to you? No, right? Basically, I'm going to rate limit myself to only one person at a time. Similarly, for software or I'm sorry, for servers, what you'll do is you'll tell the server that, hey, if one person is talking to you once, you can do it. If 10 persons are sending one request at a time, that's fine. That's how web servers are designed. But if 10 million people are going to talk to the server at the same time, the server can't handle it. Which is why you rate limit the server and say each IP address can talk to you 3 times in 1 minute, 10 times in 1 minute. Beyond that, if they talk to you, don't let them talk to you. Right? That's called rate limiting. Right? So if you get rate limited, usually you will get a 402 not found or something like that. But what I have done is certain pen testers will try to figure out the rate limit. They will try to figure out where does the software block me so that I can play within the boundaries. So to throw them off my software, instead of returning this, I'll return a random error code which they don't know. 531. It makes no sense. And 531 error, that's it. I won't say you are rate limited. I won't say there is an error in the application. I'll say 531 error. So now this makes sure that they don't know what's happening in my application and they can't break it. So you don't divulge as much information as you want to. You don't let people know that you're rate limiting them. That's essentially what the error codes are for. Yeah, so coming back to configuring. So these tools will help you configure and monitor the applications that are being deployed. Right. This is, and then after the monitor phase, the DevOps team job is done. It goes back to the planning phase. So essentially, it goes like this. It goes like this, and then back here. It goes back to the planning phase, and this keeps happening frequently, like this and like this. It keeps happening like this. Can you guess the frequency of this? How frequently it happens in one day? Any guesses? I'll give you a clue. When they were development and operations team were separate, it will take 1 week for one build to go to production, which means if I want to make one change, it will be tested for 1 week, and at the end of the week, it will be pushed to all the servers. It's 1 week, minimum 1 week. Right now, can you guess the frequency with which this happens? Can you Google how frequently does Twitter deploy to production? How frequently does Google deploy to production, Facebook, anything? Any company you want. Like, what are the numbers? How much? 50 times per day. Anyone from here? 50 times per day. Before I could do one build in 1 week. Now this cycle happens 50 times per day. So you see the gain in speed that we have here. If you want to make one change, you just need one of those 50 times per day to make that change. This is what DevOps has done to the software industry basically. Right now, 1%, 2% of all the softwares that you see out there, of all the websites that you see out there, are done using the traditional methodology where there is a software rack, etc., etc. Now, this is it. This is the culture now. People follow DevOps culture. Any questions on this? Yeah. Yeah. There's a what? Mm-hmm. like the fault I was talking about was the previous cycle, like during the waterfall model. This is agile, exactly. So like agile is basically DevOps. You guys can understand agile is basically DevOps where you deploy the changes as fast as possible. Previously, the waterfall model cannot use agile because it's not fast, right? So this uses something called an agile methodology or Scrum. You can call SCRUM, right? Yeah. Like any other questions? Okay. Basically, what I wanted to say is coming now. So there's something called CI, CD, and C deployment. So the differences between this is, if you see, I've integrated Splunk in configure and monitor. I've integrated like Datadog, all the different tools, right? All of this gets like integrated within each phase. That's called CI, a continuous integration. Because throughout the cycle, there is some sort of integration. In the planning phase, I use Jira, which is basically Scrum. Jira is a way to track tickets and see whose ticket is in what name. And then during the creation phase, I have like IntelliJ IDEA or VS Code or something like that, or like a tool which I use for deploying, for developing the software. In the verification stage, I have a lot of tests that are running. For example, like Selenium test cases or etc. etc. In the packaging, I use basically Docker. For releasing, I use AWS Fargate or AWS Code Deploy. These are all AWS services that are there. And during a configure and monitoring, I may use Splunk, Datadog, etc. So if you see in each phase, you're integrating different tools. That's why it's called continuous like integration. And in continuous delivery, if you see during the release phase, the software gets delivered as fast as possible, 50 times per day. That's CD, continuous delivery. Continuous deployment is basically in the deploy phase, where like basically the release phase, CR, right? So my job in my company is CI/CD security. Into all of these phases, I'll be introducing a security element in it. That's my job. I'll explain more on the way, right? So the advantages of DevOps are basically you can deliver faster. It's of higher quality. This is the theory. We'll just move on, right? So now we'll see basically writing and executing scripts on like Linux terminals. Here, what I'm going to do is I'm going to execute simple scripts on a Linux terminal. For example, if you have a virtual machine in your system, you can open it up and just run the commands. If you have the virtual machine ready, not we can do it here. In the meantime, if you have any questions, you can feel free to ask, right? So basically, what you're doing on your virtual machine, I'm doing it on the like internet using a free virtual machine software. Can anyone tell me any Linux command you know? Anything? Hmm? ls. Yeah. Sorry? What's not visible? one second. Is this fine? Anyways, I'll read the commands I'm doing, right? So now you have a txt file, and you can read the txt file, etc., etc. So these are basic Linux commands, right? What if I do something like apt get there is no admin password for this. So basically, there is something called apt, which is a package manager for all the Linux systems. Whenever you open up a Linux terminal, you're going to have to update all the packages that are there in your software. Windows update for Linux is apt get install or sudo apt get install. Sudo gives you the admin privileges, right? So these are some of the basic Linux command that we've seen. Now, what we're going to do is do the exact same thing or run a similar set of commands on a DevOps pipeline. So what essentially a DevOps pipeline is when you open up a terminal like this, you're opening a thread inside the CPU. So a thread is basically a small process which talks to the CPU and starts executing commands. If you followed your operating system's paper, is Kartika ma'am there? Yeah, good. So she took my operating systems paper. So if I screw something up here, she'll kill me. So yeah, anyways, so basically, whenever you open up a Linux terminal, it communicates with the CPU in a way and tells you that, hey, these are the commands I want to run. CPU runs the commands and gives back the response. That's essentially what happens. In a DevOps pipeline, what happens is you don't have this. You have the same operating system, which is Ubuntu OS, in an EC2 instance. Remember, like what I said about like Amazon Web Services? Somewhere inside a submarine, submerged under the ocean, somewhere in millions of servers, you will have a portion of one server which is allocated to you somewhere. That one server will be hosting thousands of operating systems like this, within which you'll be like allocated one operating system. Inside that operating system, you will have access to a terminal like this where you can run your commands. That is what a DevOps pipeline is basically. You're going to run your code on a terminal that exists somewhere else on someone else's system, somewhere in the world where you don't know. That's basically what a DevOps pipeline is. So now we'll just use DevOps pipeline. One second. There are many different SCM providers, source code management, GitHub, GitLab, etc. Here we'll use GitLab, right? So you all know how SCM works, right? So GitHub and all, pull, push, like all that is good. So now inside my SCM, I have two repositories. One is damn vulnerable, a Python app. One is DevOps init, right? Like init is a keyword we use for like initiate or like initialization, right? So these are two repositories that I've created with some sort of a code inside it, right? So if I go into the DevOps init pipeline, init a repository, as you can see here, there is a getting started, like add your files, git. These are all related to SCM. But what interests us is this YML file over here. Every pipeline, whatever code you want to execute in a pipeline, you talk to the pipeline runner in a format called .yml, or more formally known as like YAML, YAML, right? And it's always a hidden file. For example, if it starts with dot, it's a hidden file. Your file directory won't be able to see it. For example, over here, here I'm making a new file .abc.text. If I do ls, you will not be able to see .abc.text. You will just be able to see the previous one that I did. However, if I do ls-a, you'll be able to see .abc.text because it's a hidden file. If a file starts with dot, the file directory won't consider it as a normal file. It's similarly, over here in my repository, I have a .gitlab-ci.yml file. Every repository has a default file like this, where if you want to run the repository, you tell the DevOps pipeline that, hey, .gitlab -ci.yml is the default file that you have to run if I want to run the repository, right? So now if I open this up, you will be able to see some commands inside. Leave all this. So you see all these things. Is it visible? All right. Is this fine? Okay. So I'll just skip all this and go to these two commands. Can you see these two commands? Echo compiling the code, echo compile complete. Leave all the other commands. We'll get to it later. So essentially, whatever you're doing in a Linux terminal, which is echoing something or ls, etc., like whatever you're doing the exact same thing here, right? The only difference is it's not your computer, it's not your terminal, it's someone else's terminal. What are the advantages of this? Can anyone tell me? Why would I want to do this? Why do I need a pipeline like this? Why can't I just do it in my terminal? Any guesses? I gave you the answer before. I can't hear you. Exactly. That is one of the most important requirements, like hardware restrictions. This laptop can host only 16 gigabytes of memory, 512 GB SSD. That's it. So what if I told you the instance in which I can deploy this code can have 200 GB of memory, 216 GB of memory, 232 GB of memory, 1 terabyte of storage, and it does not take you 2 days to go buy the laptop, come set up your terminal. No, within 1 second you get that instance deployed to you. That is the scale with which you can with which you can deploy the code and run your code. Where this becomes helpful is, let's say you're running a mission to Mars, right? The computing power required to run a simulation of a robot cannot be done in this laptop, cannot be done in 10 laptops like this, even if you chain it together. For all of that, you need MX5 large instances on EC2. So MX5 large instance is basically a huge computer with a lot of computing capacity within like AWS's environment. It's called EC2, Elastic Compute. Elastic Compute is basically where you can run instances like this or run like Linux terminals, etc., at scale, right? So if you want, I can show you some of the, yeah. Yeah, so you see this M7A, M7G, Mac, M6G, T2, T3A, all these are different types of instances. So if you see here, it has up to 3.7 gigahertz, fourth generation AMD processors. If you click Mac, these are Mac instances. Instead of having a Mac laptop, you have a virtualized Mac which is being deployed somewhere, right? So if you see here, it's run by an Intel 8th generation 3.2 gigahertz, i7 processor, 6 physical and 12 logical cores, etc., etc. It's good for T2. See this. T2 unlimited instances can sustain high CPU performance. Yeah, up to 3.3 gigahertz Intel Xeon scalable processor, the burstable CPU. So basically, these are the different types of computers that you can spawn up depending on your requirement, right? So right now, what we have here is a normal one, a normal EC2 instance. Okay, so let's edit this. Let's remove all this. Tell me like any Linux command you want. Any command. Okay, how about this? Let's make a text file and write ACM into the text file and then echo the text file. Like how does that sound? So can you tell me the commands for that? Like how do I make a file in Linux? Huh? Cat. No, cat displays the file. Nano, yeah. So basically what we do is we use the touch command. A touch command will create a new file and just leave it at that. So let's say acm.txt, and into this file, let's put, we'll do it in a separate file. Echo acm inside txt. This should work. Or we'll just do ls for now and see if it works, right? So for every pipeline file, there is a template that you have to follow. And over here, you see this stages over here, build, test, deploy. Remember how these map to a DevOps build now? Build, test, deploy. Where have you heard these? In the DevOps cycle, right? Like you remember the cycle I showed you? Sorry. The build phase is basically where you take all the requirements that a software has and you build it within the container. Remember I said there's a container, you need the requirements. That's the build phase. The test phase is where you test to see if everything works fine or not. Only after you confirm that everything works, you're going to go to the deploy phase and start deploying whatever code that you want to deploy. Right now, what I'm going to do is I'm going to start one job. In the DevOps terminology, every task that you need to do is called a job, right? For example, if you want to install Python, you have a Python job. If you want to delete Python, you have a job called delete Python, etc., etc. These are not predefined jobs. These are names that you're going to give for the job, right? For example, over here, build job is something that I'm giving the name in a stage of build over here. It doesn't work. So this is the name of the job that I've given, and this job will be running in the build stage. It will not be running the test stage or the deploy stage. So inside stage build, so this is one space bar. If you do one space, it appends you to only one space, or if you click the tab button, it will take you two spaces next. You can either use a tab space of 2 or a tab space of 4. This is the general accepted format for every .yml file, right? So once you do a tab, it accepts the format, and inside the stage build, I'm going to run one script inside it, right? Inside the script, I have a x number of commands. Any command you want, you can run. So I'm going to echo something like and something like this. Then I'm going to touch a file called acm.txt, and I'll run one more command to see where we are, called pwd, right? Now, if you go on top here, it says the pipeline syntax is correct. If I enter a space here, if I enter a space here, it says this GitLab configuration is invalid in line 19 at column 1. So basically, it checks the format of the file. Right? So I just do a tab. Now it should be correct. Now all I have to do is init update. This is a commit message, right? Init update 1, something like this. The commit changes. Once you commit any change into a repository that has a default YML file, it will start running the file. It will start running the pipeline. Basically, that's what you see here. Pipeline, some number running for this commit that I've given, like init update 1. Let's see this pipeline. So this is the parent, this is the pipeline. I'll open the pipeline. And remember I said there is one job called a build job. So now when I click the build job, as you can see, this is these are all commands that are run by the job to make sure that the environment is set up ready. Right? So you can skip all this and go directly to here. The first command we wanted to run was echo welcome to SSN. And what's the output? Welcome to SSN. Next command was touch acm.txt. It completed it, and hence there is no output over here. Next command was ls. ls will list all the files, right? So you have readme.md and acm.txt. This acm.txt comes from here. So touch acm.txt. Then you have print working directly /build /sample DevSecOps /DevOps. So basically, whatever you do in a Linux terminal, you've done in a DevOps pipeline. This is essentially what DevOps is. This is a simple explanation of a pipeline that you see here. Usually, a pipeline code is huge. There will be 5 stages: build, build, configure, test, deploy, monitor. These are the 5 stages of a DevOps pipeline, where in build stage, you will start packaging the requirements, and in configure stage, you'll make sure that the versions are correct. Then you'll test out everything and see if it's correct. And then you'll deploy your code using on huge code. So everything that happens in modern day software happens in a pipeline like this. Okay, and that pipeline will not look like this because, let me show you. Here there is only one stage called build, and there's only one job called build job. Usually in an enterprise grade pipeline, you will have 5 stages like this: build, test, deploy. There'll be multiple stages, and the pipeline will go through each job in each stage. So over here you'll have 3 stages. Here you'll have 3 jobs. In the next test stage, you'll have 10 jobs. Each job will do one specific task. So can you guess why this segregation is there? Any idea? Why do I have? Yeah. No, but here I did 3 commands in one job. It still worked. Okay, so that option is there, you're correct. So what you can do is you can have multiple jobs executing simultaneously, or you can run it in sequence. So that's correct. That's one of the features. The actual reason why we have segregation between the jobs is because if something goes wrong in the build job, then you know that within that 10 lines of code, something has gone wrong, which is why you have to go and debug that 10 lines of code. Now, like imagine there is a 1,000 line code of a DevOps pipeline. You don't know where it has gone wrong. Your DevOps engineers are angry. Your like developers are angry. Everyone is angry. They have no idea what's happening, right? Which is why we have separate jobs and separate stages to figure out where exactly does my pipeline fail, right? So, if you want, what we can do is let's uncomment this, and we'll try to make it fail. I won't have enough time. But what you guys can do later on is use, yeah. So what you can do is use like another stage called deploy or something, and like inside the script, instead of echo, type echo, add one more zero to the O. Now what will happen is in the build stage, it will succeed, saying build job succeeded. But in the deploy stage, like what's the name of this? Um, Deploy job. This is the name of the job, right? Deploy job. So deploy job, you will see an X. If you ask why, it's because this command is not found. Echo O. Right? This command won't be found, so it will fail. So whenever a pipeline fails, it returns with exit code 1. If it succeeds, it exits with return code 0. Right. So here, this thing will not run. So it will exit with return code 1, and hence the entire pipeline will fail. Executing multiple bash files. As in, mhm. Yeah. So the difference between a bash file and the pipeline is you cannot run multiple bash files in sequential order. For example, you have 3 files. To run all 3 files, if I want to run the first file first, third file second, and then second file third, you can't do it in bash. Right? You're gonna have to tell bash somehow that first run this. If this completes, then run this. If this completes, then run this. Let's say 2 weeks down the line, you want to remove that and you want to add one more stage to this. You can't do all of these things in bash. It's very limited to within the instance. Whereas this gives you much more fine-grained control over all the different stages of the pipeline and the code that you put into the pipeline. Right? Not only that, over here you can also have certain monitoring tools running. For example, if you make an error in your bash file, you won't see this. Pipeline syntax is correct. When you try and execute it, something will fail. Whereas here it will tell you what has failed. And one of the more important reasons why we do this is because of SCM, which is source code management. Any change I make to the pipeline, so for example, right now I made a commit, right? If I go back to DevOps init, and let's say my entire like application has failed in production and I want to revert back to the build. You can't do that in bash. You can't revert back to your previous code because you don't have your previous code with you. You have made a change to it and you're running the bash file, right? So over here, all I have to do is revert this commit and then like run the pipeline again. That's it. It will do it automatically. So for commits, minutes ago. If I take this one, this is my the previous commit. Remember we like commented all these files. So now all I have to do is copy paste this or just run this. Usually what we do is we have a tool which we use to run this pipeline immediately without clicking on run pipeline called Jenkins. So Jenkins is a CI/CD like orchestration tool where you have all the pipelines you have. It's basically like GitLab CI, but with much more fine-grained control. For GitLab CI, you have to pay. Jenkins is open source and free. This is why many startups use Jenkins, whereas many enterprise-grade companies like Apple or something, they might use GitLab CI for compliance reasons to like SOC 2, like ISO, and all these compliance will tell that you cannot run open source tools within your system because they're not vetted, they're not secure, they're way too open, so etc. etc. There are a lot of reasons, right? So that's one of the reasons why we don't generally use Bash within Linux to run stuff. We usually do it like this. Okay, so now I'll go back to the slide. So now we've seen how we can write scripts on Linux and basically get that executed in a DevOps pipeline, right? So basically, there are different types of vendors like GitHub Actions. So inside GitHub, if I do the same thing, it's called a GitHub Action. The YAML format changes. Instead of saying, instead of coming like stage, build name, and script, it might say on push, on merge, which means if I push a change to the repository, then the pipeline will get triggered. Or if I pull a change from the repository, the pipeline gets triggered. Basically, you can control when the pipeline is triggered inside your pipeline itself. This is called a hook, H-O-O-K, hook. So what this will do is, let's say I have a pipeline, and every time I push code to the pipeline, I want it to run and send you a message saying hi. Right? So every time I push something to the code, inside the code itself, I'll say that if I push something into the repository, run this code. If I pull, run this code. If I don't push, don't pull, don't do anything, then don't run anything. Something like this I can configure inside the pipeline itself. That's a bit advanced, so we'll skip all that. And I've completed this. We've shown echo command, same script as before. Now what we'll do is, we'll come to the security aspect of this. We'll be moving out of this. Yeah. So the security aspect of DevOps. Where do you think I can use DevOps in security? Any idea? Any guesses? Let's take an example. We have an organization. They're running their DevOps pipeline. Everything is good. Under what circumstances will they introduce security into their DevOps pipeline? If an attack happens. What you've told is actually what's happening in the industry right now. People don't introduce security into the DevOps pipeline. It will run like aramco. Suddenly what will happen is some attack will happen, and then the organization will realize, oh, I don't have security in my pipelines. Let me introduce security. Let me hire Riysz. He will come do security. And like this realization happens only after an attack happens. Very few organizations do it preemptively. Preemptively as in before the attack happens itself, they're like, okay, fine, you know what? Let's introduce security here and make sure that our brand reputation is not damaged. Let's say you have an Apple iPhone, and Apple had a recent data breach saying that someone broke into their pipeline, store all the source code. Would you still consider having an Apple iPhone? Not so much, right? Similarly, Apple, this does not happen to Apple. I'm just giving an example. So similarly, there are many startups like this that are out there who have DevOps pipelines, who have code, but they don't have it securely. And hence, when a data breach happens, all their source code is stolen and they go out of market. They're gone because no customer would want to interact with a company or anyone who has been through a data breach, because it shows that they don't take security seriously, right? Which is why security is an up and coming topic these days. There's a lot of scope, but not enough people to do the job that needs to be done, right? So essentially, so now what we're going to do is, inside a DevOps pipeline, let's assume that there is an application built. That's the assumption that we're doing here. There's a huge DevOps pipeline, there's a big application, and it's already built. Build, test, deploy, everything is done. After this, what we're going to do is we are going to run security scans on that application using using Brakeman and Bandit. So you can see here, Brakeman and Bandit. So these Bandit is a tool. Bandit is a security scanning tool for Python applications, whereas Brakeman is a security scanning tool for Ruby on Rails applications. Ruby is the language, Rails is the framework. ROR, that's called. Right. So we'll get started with this. Right? So let's skip the part where we do it in a Linux terminal and let's directly do it on a DevOps pipeline. Essentially, it's the same thing, right? So I'm not going to be the one doing this. You all are going to do this. So let's see. So the first step is we have to figure out how to install Ruby on Rails, right? So can you tell me what this code does? Yeah. Where is this running? No, I can't hear you. Can you please speak up? Hmm. Hmm. So by default, like every GitLab runner has a sudo privilege. So if I introduce a sudo command here, it will work because you cannot download something into your Linux instance, install it without sudo privilege. So when I'm running apt install ruby hyphen full y, like hyphen y means yes. So when I'm running that, this particular instance does not need sudo because I cannot directly open up this instance and do something. I am bound by the limitations of this runner, of this pipeline. Inside a pipeline, I can't launch a DDoS attack because they have my credit card information. When I want to run this, I have to give my credit card information. Because if I don't give my credit card information and you go ahead and launch a DOS attack, which is denial of service, they'll bill you for misusing that platform, right? So essentially, all those attacks can't be done through a DevOps pipeline. And for your question as to where are the privileges being set, even when you run it like locally, by default, you don't have sudo privilege unless you become a super user or unless you say sudo run this, super user do, right? So over here, sudo is generally not required because by default, I should. So the privileges in like Linux work based on a tag that you can see over here. This would have gone away. So basically, there is hyphen d hyphen ch mod. That is the command you use to change the privileges of every file. Ch mod like hyphen r or hyphen w or wrx. These will determine the privileges that that file has. For example, if you don't want anyone to write to the file, you remove write privileges. By default, every GitLab CI file has one of the privileges. I'm not sure which, but by default, that is the privilege, and you can't change it unless you use sudo. Depending, so where are you setting the filter? Depending on who runs it, yeah, you can do that based on the user filter. For example, if I open my organization account, my GitHub user ID is cb-Riysz Ahmed. That's my ID. So within the pipeline itself, you can use the filters by saying who triggers the pipeline. If I trigger the pipeline, I can access only a certain piece of code. You can do that using a filter. If you want, I can show you the syntax of how to do that. Yeah. So using this like on filter over here, you can configure on what like event you want the person to run the program, right? You want the person to run the pipeline. So over here, there will be some sort of syntax which will tell, hey, if the user's user ID is cb-Riysz Ahmed, only then you can allow it to do. There are certain syntaxes that like allow you to do that. You have to dig a little bit deeper to figure out what exactly is the syntax, but you can do it. Pull request target. No, you have to dig a little deeper. So, but it's possible. Like what you're saying is possible, because if you can do it based on pull requests, push requests, merge PRs, and all that, of course you can do it based on like user level. Your use case is generally not done in industry, because in industry it's not like if he does it you have to run this command. It's generally not like that. In the industry, that the types of filters that we use are a pull request based, or merge based, or push request based, or like remote tracking based. So only in these sort of scenarios we'll trigger the pipeline. So coming back here, um, I'll explain each command. So my intention was that I would have you guys figure out the command to install Ruby, install Brakeman, run Brakeman. But I took up too much time for the DevOps explanation, so I'll skip all that. Hmm? What? Ruby. 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 That red color gem. Ruby. Ruby on Rails. Ruby is a programming language like Java or Python. You have a programming language called Ruby. Okay, and there is a framework on top of which you run Ruby code. For example, if you want to run Java code, you need to have a Gradle or Maven. These are the frameworks on top of which you run application code. Similarly, for Ruby, you can't just, I mean, you can run Ruby code, but if you want to host a web application or an entire application on Ruby, you need Rails, Rails. That's a framework on top of which you will be running Ruby code. Yeah. So basically, Rails will provide you the web application, like multi-tenancy and all that Rails will provide. Ruby will tell the business logic, like what to do with the request and all that. Okay, so we'll skip all these commands. Have you heard of git clone? Hmm? So what git clone will do is whatever link you pass here, which is a GitHub link or which is a repository link, not necessarily GitHub, it will clone that repository and make a copy of it, as long as the repository is public. If the repository is private, you have to set up GitHub authentication. Only after you authenticate that, hey, I am the owner of this repository, you can clone it. Right. For example, over here, I'm trying to clone a repository called rails.git. So I'll show you something interesting. This is basically a repository called Rails Goat, G-O-A-T. Right. So what this repository basically does is it's a vulnerable version of the Ruby on Rails framework. Why would someone want to develop a wantedly vulnerable version of a framework like this? Can anyone guess? Why would I want to wantedly develop something which is vulnerable? No, for talks like this. In talks like this, I cannot bring a secure application and show that I can break it because it's secure. If I can break a secure application, I'm not supposed to be here. I'm supposed to be in my company fixing it, right? So basically, so you have DVPW, a damn vulnerable Python web application, DVW, a damn vulnerable web application. These instances are built to teach you web security, to teach you how to break into these applications. It's wantedly built like that, right? So this is Rails Goat. This is a custom fork of Rails Goat. By fork, I mean, let's say there's a plate of 10 idlis and you take one idli. That's called a fork, right? So essentially, you have one repository. You'll just clone it and start your own repository from there. So, essentially, this is what I'm trying to show. So this is right here. But fine. So you can think of it like this, right? There is a straight line like this on which the main repository is running. There's a huge straight line. I'm going to take a fork of it and run my own repository from here. So the main line will be here and my a forked repository will be here. At like any time during my time in which I'm using the repository, I can try and merge my repository with the main one through a pull request. A pull request is basically where you take one branch, which is a forked branch, a different branch, and try to merge that branch with your main branch. So basically, you don't have differences in code between the two branches once you merge it. Like once you merge it, the two branches will have the same code. However, if there is a difference in code, you will be able to see it like this. Yeah, you see this with 7 additions and 0 deletions. This is how you'll be able to see the code between two branches if there are changes. So let's say my main branch is this, and this is the branch I'm trying to merge with the main branch. So when I'm trying to do a merge, it will tell me, hey, there are 0 deletions, which means 0 lines of code are deleted, but there are 7 additions. 7 lines of code have been added or modified. So that's essentially how Git works, right? So this is a green in color. You can't see it here, but all of this will be highlighted in green color, very light green. It's not visible here. So if you open up the repository in GitLab, right, you will be able to see all the different tabs of here like manage, plan, code, build. Our pipelines come under the build stage under the pipelines. Right? So here you'll be able to see all the different pipelines I've run for init, update, apply, etc., etc., etc. And as you remember, you asked a question: why can't I run it on a terminal? I won't have this visibility in a terminal. Like how many different pipelines were run? Why did my pipeline go wrong, etc., etc. Which is why we have this CI tool, the continuous like integration tool. Right? Let's edit this and. Yeah, so now we are going to clone this Rails goat, which I told you the intentionally like vulnerable Rails application into a folder called web app over here. You can name it anything you want, web app Z, web app 1, anything. So we are going to clone this repository. It's a public repository, which is why I was able to access it when I opened it in a new tab. So after this, what I'm going to do is I'm going to cd into this folder, change directory. So which means you're going into that folder. And then I'm going to run a command called apt update. Why apt update is necessary is because any instance that you spawn up will not have all the updated packages. You have to open up the instance and then update it once. So it will talk to the Ubuntu server, Fedora server, Debian server, etc., and it'll ask, hey, this version for this package I have. What version do you have? It'll ask. Then the server will say, I have this version. Do you want it? Which is where I say -y over here, yes. To say that yes, I want to upgrade the version, or yes, I want to install this package. One limitation of a pipeline is it's not interactive. As she said, a Linux terminal is interactive. It can ask you questions, you can answer it over here. If I don't do this -y over here, somewhere during the installation, it will ask me a question. Do you want to install this? Enter yes or no. When a pipeline is running, I don't have access to the code, which is why preemptively I say yes, I want to install using the -y tag. So pipelines, while they're not interactive, there are workarounds that are always present in every single repository, such as this -y tag, to make sure that that interaction element you can give your input before you run the application itself. Right. So now we are running apt update to download all the latest packages. Now, downloading the packages does not mean I'm installing the packages. I'm downloading the latest versions of the package as an index file. For example, this package, this version, this package, this version, just that. That's what apt apt update does. When I run apt install, that is when it will install all the latest dependencies. It will take 10 minutes, 15 minutes, 20 minutes, etc. But here what I'm going to say is, I don't want to install everything. I want to install Ruby full. Remember I said we are running Ruby on Rails. So I want to install Ruby full with the -y tag, because somewhere in the installation process, it will ask me a question. Do you want to install or not? I want to say yes, which is why I'm going to say -y here. And up to this point, things are pretty clear. I'm just downloading a repository and installing Ruby. These are two separate tasks. After this, there is something called gem install break. In Python, have you heard of pip? So what is pip? Package installer. Similarly, for Ruby, there is gem. Pip is gem for Ruby. It makes sense because Ruby is a gem, right? Red color Ruby. That's why they call it gem. So you do gem install breakman. Breakman is the name of the security tool that we want to run, right? So gem install breakman. You cannot specify the version. If you want to remove it, if you want to keep it, I just mentioned the version. After running this, every tool will have a help command or a man page. It's called man page is basically which will tell you how to run the tool. Generally, it's -h. It will open the help page. You can use any. You can use -help or breakman man. Breakman space man, which will give you the man page of it. So after you run the help command and figure out what are the different commands that are there, I am going to run breakman -f JSON t result.json. So this is called a pipe operator. What a pipe operator does is everything to the left of this will be run after. I'm sorry, before this command is being run, right? So this will output a JSON file, and this JSON file is taken as an input for this command, and this result of JSON is then created. So basically, whatever JSON output you see on screen, I'm storing it in a JSON file. That's all I'm doing using the T command. So that's basically what this does. Is it correct? Python syntax is correct. Now, when I do a commit changes, will this run? I'll share you access to the code, don't worry. In fact, use this link. github.com/r1yaz/ssn_acm_DevSecOps. It will give you access to all the code that I'm using in this lab. If I zoom this, that probably won't zoom. Yeah, I know. They gave me a journal. So this is the link for the repository where you'll find all the source code that all the code that I'm showing you. Yeah. So I'll say a commit message saying breakman run on Rails good -1, and here this asks me which branch do I want to commit to. Remember, I said I can fork my own branch. Once I fork my own branch, I can commit changes to my own branch and then merge it with the master. Now, where this is helpful is if you have a team of 10 software developers, you can't have 10 developers working on the same main branch because 2 of them might commit at the same time and will cause a commit clash, which is where all the branches feature comes in helpful. Each developer will have their own branch. They'll do whatever they want with their branch. After they're sure that the changes they've made is exactly the change which the PM has requested, they will raise a pull request. A merge request, a pull request basically from the main branch to their own branch. So basically, the developer's branch is here. This is the main branch. So the developer will be like, hey, I've made the changes I want over here, and I want to merge it to this. And then a senior developer will come and review it and say, okay, fine, this is good, this will work, merge. Once they merge, this branch will then be merged with this branch. The branch won't get deleted, it will still exist. But these two branches, instead of being like this branch being ahead and this branch being behind, it will come to the same page because they're the same branch. right? SCM takes a bit to understand. Once you work with SCM, you'll understand. Oh, no matter how much I do this, it won't make sense much. As only after you run the commands git push, git merge, git raise PR, only then it will make sense. But yeah, so if I commit these changes, will the pipeline run? Will the pipeline run? Or will it get cancelled? Or will it not run? What's the name of the file? Uh, yeah. Just name of it. Okay. The answer is right here for you guys. I'm using pipeline editor, which means the pipeline will run. If I just create an update directly to the pipeline file, like will it run then? Any clue? It will run then also. Because remember I said the name of the file is gitlab-ci.yml. As long as the name of the file is the name of the default file, any change I make to the file will trigger a pipeline, no matter what I do. If I create a separate .yml file saying riysz.yml, no matter how many changes I make to that riysz.yml file, the pipeline won't run unless I go and trigger the pipeline. So every repository has a default file called .gitlab-ci.yml. If you change it, the pipeline runs. So readme.md. If you change the readme.md file, you see this? This is the readme.md file. Any change I make to readme.md file will be reflected over here in my repository's home page. So essentially, that's how Git works, right? So if I make a commit here, it will run the pipeline. So you can see here, in pipeline status. Yeah, so the pipeline number something something is running for this commit. So I can directly say view pipeline, and it will take me to the build job over here, right? So if I click on build job, it will show me the Linux terminal where all the commands are being executed. So it won't show you one by one command. It will quickly execute everything and then show you, because the number of commands we've given is rather small, right? We just give it a minute or two. Yeah, done. So why is it exiting? Why is it like exiting with error code 1? Any guesses? Okay, I'll do one thing. I'll explain up till here, and then you tell me why it exits with error code 1, right? Okay. First was echo welcome to SSN. Then was touch ACM, LS, PWD, git clone. Now we are doing a git clone command. All of this Rails goat is being cloned into like web app. We are feeding into web app. We are running apt update, right? So it will run all get requests to Debian. Remember I said the Debian server. These are the links for the Debian servers. So it will run all the fetch the package lists and then update the package list. Now when I run apn, like apt install Ruby full, it will install the entire Ruby stack over here in all of these commands over here. After this, I'm saying gem install Brakeman. It will install Brakeman, done over here. And Brakeman-h will tell me how to run Brakeman. As you can see here, usage, Brakeman options. Like -n means no threads, -p means you're telling the path before itself. You can specify which rails to run for Brakeman. And there are a lot of options over here. We'll just skip all this. It's not relevant for us. Yeah. So now over here, what I'm running is I'm running Brakeman on this Rails goat repository, which is the vulnerable repository. Remember, I CD'd into web app, which means I'm inside the vulnerable repository now, which is where I'm running Brakeman, and I'm storing the output in results.json. So this is where the scan is being run. All of this is where the scan is being run. And somewhere over here, the scan is completed over here. See, text finished, collecting results. This is the reporting. The report will be a JSON file. A JSON file is basically a key pair attribute sort of a thing. This is the key, that's the value. Key value, key value, key value. So this is just a list of basically all the keys and the values that the repository scan has found. So there are 19 total security warnings. These are all the scans that have been run, the basic authentication scans, the CSRF scans, etc., etc. I'll just skip all this. And yeah, this is one of the warnings that has found. Remote code execution. Anyone knows what RCE is? So what is RCE? something like that. So RC is basically in a simple example. This is being run in a Linux terminal somewhere, right? Remember I said if I can execute a command on that without access to the pipeline or without access to the admin interface, it's an RCE, remote code execution. So it has found a remote code execution inside this file, password resets controller dot ruby. So my job as a security engineer in my company is to find all these vulnerabilities and fix them. So I'll go into the code, see why there is a remote code execution. So remote code execution happens when you do an operating system call without passing parameters into it. Yes? No issues. So the different vulnerabilities that exist here, to fix them, you have to figure out where in the code this particular vulnerability like originates from. Remote code execution happens because of an unsafe call to operating system calls. For example, if you're trying to run ls and I do ls pipe uh, uh, cat slash etc slash password, right? What I'm doing is you show me the ls, fine, but I'm appending one more command to it and saying also show me your passwords file. That's how RC is done. So there is an RC vulnerability inside this Rails goat expected. It is supposed to be a vulnerable application. And then what it does is it will store all of this in a results.json. Yeah, in a results.json file, and then it exits over here. Why does it exit? Any idea now? Why does the pipeline fail? As you can see over here, the pipeline has failed. There is an X over here. Why did the pipeline fail? Our previous pipeline succeeded when we ran just CD and the basic commands. Why did this pipeline fail? Any clue? Just guess. Why did it fail? Why should this pipeline fail? Think from an organization perspective. If you get this right, I'll give you an internship. Okay, so I'll tell. So think from an organizational perspective. I am running the DevSecOps pipeline. This has failed, which means something has gone wrong with the pipeline. Here, the only thing that has gone wrong is it has found some vulnerabilities. If a pipeline, if a security scan finds vulnerabilities, should the pipeline be allowed to succeed and proceed to deploying the application, or should it fail? It should fail. That's exactly what has happened over here. Exit port 1, because there are vulnerabilities found, the pipeline has failed. Anything beyond this will never be executed. Over here, it's the pipeline failed and say, that's it. To go back, fix the vulnerabilities, then come back. And then you have to rerun the scan. Only then will you see exit port 0. Oh, yeah. All of these are vulnerabilities. Everything you see here are vulnerabilities. How do I know? Unsafe reflection, remote code execution. All of these are vulnerabilities. And possible command injection, it's a vulnerability. Format validation, it's a vulnerability. Not exactly, but fine. Mass assignment, this is a vulnerability. So when you run a security tool, which is supposed to find vulnerabilities, it will give you vulnerabilities. It's not going to give you something else, right? So yeah, this is the very simple overview of what the DevSecOps pipeline should look like. And now I'll show you what my pipeline looks like. There is one more code that I wanted to show you. I can't explain it as much as I did right now, but similar to what we did for Ruby on Rails, you guys are more accustomed with Python, right? I'll show for Python, right? So for Python, I'll just open directly the YML file and explain. So there's git clone dvpwa. Dvpwa is a damp, vulnerable Python web application. It's an intentionally vulnerable web application built using Python. After that, I'm cding into the dvpwa file and I'm installing Bandit, pip, using pip, not gem. This is Python, right? And if you notice, this line is extra over here. Image colon Python 3.6. Why have I included this? If just think about that. And right now, pip3 install bandit, basically it installs bandit. And then I'm going to run bandit on this repository, dvpwa. This is the output of the pwd command. Remember, we ran pwd build slash sample whatever, dvpwa. Whatever I've cloned here, I'm just going to run bandit inside that. It will generate the report. What does this do? Image Python 3.6. Any ideas? Hmm? Version 1. So why am I just passing the Python? Where have I installed Python here? Remember last time we installed Ruby? Why haven't I installed Python here? This is where pipelines are effective, because in pipelines there is something called Dockerized containers. I don't have to install a Python using this step. I can just say use the image of Python 3.6, which means a pre-built image of Python 3.6 is taken and then used. I'll show you that in the pipeline scan over here. So this is the latest pipeline that I ran 16 hours ago. So if you see the pipeline, there was one build, which was the bandit scan. Let's open it up. This is the build job stage. And this is basically the whole scan, right? So I'll show you where the Python is being used. Yeah. Pulling Docker image Python 3.6. Because I said the image is Python 3.6 here, it pulls the Docker image of Python 3.6 and uses that to run the Python commands. Similarly, I can do for Ruby. All you have to do is instead of installing Ruby, just type Docker Ruby. Ruby official image is here. Now what you need to do is figure out the version that you want. This is in see 3.3.0 preview 1 hyphen book form. Now what you have to do is like image colon this entire thing 3.3.0 hyphen preview 1 hyphen book form. It will use that particular Ruby image for you, and you don't have to install Ruby. The reason why all of this is there is because I don't want to waste time, precious time, installing things inside a pipeline. Instead, what we do in the industry is we create Docker containers for every single thing. Docker container on how to prepare idli, Docker container for dosa, Docker container for literally everything you want. So that every time someone wants to install Python, we don't tell them run this command, do this, do that. No. We just tell them take this container, run the container. It will take care of everything for you. That's the power of Docker. Right? So you can install literally anything in the world you want inside any pipeline you want using just the image tag. It will use that image. Kubernetes. Okay. So do you know how one Docker container can be managed easily? But when there are multiple Docker containers, you need it's like a multi-cluster setup. That's a completely different thing. If you ask me Kubernetes, I can explain it in huge, but to simplify the Kubernetes, what I can say is managing multiple containers is done using Kubernetes. K8s it's called. That's simply good. So yeah, that's it. If you see here, this is where it pulls like the Python repository. It takes it clones dvpwa. It goes inside. It installs bandit. If I don't mention Python 3.6, this pip3 will fail because there is no Python environment for pip3. Pip3 won't even be there. So what I have to do is I have to first make sure that Python 3.6 is being used, and then say pip3 install bandit. Like otherwise it won't work. And then once it is installed, you basically run the bandit scan, the bandit -r thing, and once it runs, see, it shows one medium one, the use of insecure MD2. These are hashing algorithms, MD2, MD4, MD5, etc. And the scan fails because at least one vulnerability is found. This is another sample use of the DevSecOps pipeline. I think I'm not allowed to show the entire source code from my company, but I can show you an example code, right? Yeah. So this is what the output of. I don't have the code with me, but maybe I can. Yeah. This is something which is what dev. Can you guys see this? Yeah. So this is exactly what an enterprise grade DevSecOps pipeline will look like. For example, the agile teams will first use Jira to figure out where to deploy what, etc., etc., all that. And then inside Git, there is something called Git leaks, which will detect all the secrets you commit into a repository. For example, if um, if you want to access AWS through your command line, you need to have an access key and a secret key. These two keys are needed, right? If you have to keep these keys a secret key. If you don't keep them secret, I can use your AWS account, right? But some developers don't know this. What they'll do is they'll commit these keys into the repository and make it public. So to detect all these things, I use something called Git leaks, right? So first, the secrets will be detected. So this phase is called Git leaks. Next is called SBOM, Software Bill of Materials. Why Software Bill of Materials is necessary? Let's say there's a zero-day attack. Do you know what a zero-day like attack is? Out of nowhere, there's an attack on one package, right? And I don't know where in my software that package is being used, which is where the SBOM is used. SBOM will tell me exactly what are the dependencies of my software and where the dependencies are there. Log4j, anyone heard of it? Log4j, right? So in my company, when Log4j happened, we had no idea. We had no idea what are the dependencies we have on our software. So what we did, we built an SBOM, and in the SBOM, we just search Log4j. It will tell you what all microservices or like the monolithic applications are running Log4j. And then you have SAST, Static Application Security Scan. Unit test is done by the QA team. You have Docker file scan. This will scan for security vulnerabilities inside the Docker file itself. Remember how you found a Docker file for Python? Every Docker file basically has a set of commands. Instead of running the commands yourself, you'll like run it as a container. So when I'm talking about a Docker file scan, you're running a security scan on the commands inside a Docker file. To install Python, if I add one command there to cat etc password, you won't know. You will install Python and keep moving on, but I'll have your passwords file, right? So this Docker file scan will scan your Docker file, which is used to install whatever Docker things, and it will tell me what are the vulnerabilities inside that. Then you have build. After all these scans are done, you'll do build. You should not run SAST after building because SAST is a static scan. It's run on the code base. It's useless to build, deploy, and then run SAST because SAST by itself means you're running a scan on the code. Your code is ready. as soon as the developer is done with his Jira ticket and commits the code into the repository. Basically, you can exchange this with this. No worries. You can skip these two anyhow you want. After all of this is being done, I don't have time to cover everything, so I'll just say what DAST is. DAST is Dynamic Application Security Scanning. This cannot be done over here because to run DAST, you need to have a running instance of the application. For example, if you're having a web application, it should be deployed somewhere. Unless it's deployed somewhere, you cannot run DAST. You can run SAST on the source code. DAST is run on the application itself. You can't run DAST on source code because it's a dynamic testing, right? Only if the application is running, you have the URLs, you have the cookies, you have the requests, you can run DAST. DAST uses tools like burpsuit, Nikto, OASP-Zap. These are certain tools that you can use to run DAST. For SAST, basically what we did right now is SAST. Brakeman, Bandit, all these are SAST scans. And smoke testing, API testing, let's just skip all this. Kubernetes over here. K8s, CI scan. Kubernetes manifest scan, all of this happens over here. So this is what an enterprise grade CI/CD pipeline will look like. After all of this, right, there are two deployments being done. One is in the test environment first. First, you will test if all of this works properly. Only after that, you'll go to the production environment and deploy it here, and then you'll monitor these two environments. So the code for this probably be 2,000, 3,000 lines strong. This pipeline will take 10 minutes, 15 minutes to run. This cannot be included in the pipeline. DAST takes hours to run. So it's not smart to include DAST inside a DevSecOps pipeline. This is done separately. So yeah, that's all about DevSecOps. Any questions? Any questions, guys? You can ask me questions related to your career or like anything of the stuff we've covered so far as well. Oh yeah, just access this link, right? A tiny.cc/careers in cybersec. So I have a PDF for all of you with a lot of useful cybersecurity resources which you can use to learn and stay safe on the internet. So that will help you all. If you want to connect with me on LinkedIn, tiny.cc/Riysz capital L capital I. Sorry, I'm in the middle of a talk. Can I call you later? Yeah, okay, sure. Thank you. Yeah. Any questions so far? No, because web development is the part where you actually develop the web application. DevOps is the part where you deploy the web application. These two are not really, you don't need to know one to know the other. It's good if you know how it works, but it's not needed at all. For DevOps, the basic skills that you need is scripting, bash, networking. You need to know networks, so don't skip your networks. Basically, that's it. A bit of Docker, a bit of Terraform, all that. But that's all you need for DevOps. Huh? What's a good place to learn DevOps? A GitHub Academy, Git CI Academy, Udemy, all of these are good places to learn DevOps. Internship for students. So at Chargebee, we have internships at the security team. Right now, we already have one intern who's working with us, but maybe in the next 6 months or something, we might be looking again for interns for our team. For interns, if you know your fund. See, I don't expect you to come and show me a like DevSecOps pipeline and tell I know security. If you know it, awesome. We're definitely going to hire you, but have your fundamentals correct. Networks, TCP, DNS, port. For example, port 80. Like, what does it represent? Port 443. Like, what does it represent? HTTPS. Basic stuff. Just this. And if you have some interesting projects to your name, that would be good, because otherwise, anything, anything at all. See, cybersecurity. The thing about security is it's a huge domain. So you can't just be like, I've learned security, right? If you know web application security, you need, that will help you win from the web application perspective of things. Let's say if you know Docker security, you can help the DevOps team. So any background you come from, you just need to know a bit of security, which will help you, take all that previous knowledge you have and put it into a perspective of security. That's all. So I didn't, like, when I graduated, I wasn't like, I'm going into DevSecOps, I'm going into VAPT. No, I just went just like that, and things just fall in line. Is like what I'm trying to say. Capital L, capital I, and the R must be capital. That's my LinkedIn profile. In terms of projects, have good projects. Don't copy paste code from internet and say it's your project. I'll find out. So have unique projects. For example, whatever I've done here, take my code, improvise it, make it more useful. For example, let's say inside the college, you're learning Java or something, build a Docker container for Java. That's enough. Basically, like whatever you do to install Java, just take those commands, learn how to create a container, put those commands inside. That's it. Your Java container is ready. So things like this will help. Knowledge of the cloud concept is also very helpful. For example, AWS EC2, RWS, SNS, simple notification service. What are all the different AWS services that, how can I use these services? Build an AWS project. For example, if I create a push request to my GitHub repository, I want an SMS notification. Do that. Simple. EC2. No. So AWS, so the cloud computing concepts are the same. You can rent instances, you can have a relational database service. They're the same concept. Every vendor will implement it differently. AWS has EC2, like Azure has compute instances. Google Cloud has something similar. They just name it differently. So if you learn AWS EC2, you basically know everything else. You can work cross-platform is what I would say. They're the same thing basically. Any other questions? Anything related to your career, or how you plan to proceed forward with security? My experiences in security, anything at all. Don't feel shy. I was once one of you guys. I was sitting there. So I know. Good question. So I'll tell you what I did. 5 years back, when I was in SSN, I skipped DSA. I don't know linked lists. I don't know heaps. I don't know trees. I don't know anything. I skipped it. So my goal was, I'm going to work in a security company. If you're going to ask me a DSA question, I'll walk out, because I don't know DSA. Very frankly, I skipped any interview that came to me. If I didn't know how to code link, I didn't focus on that, because my passion was security. My passion was that I want to learn how to break a company. I want to learn how to secure the company. That was my passion. So I took the risk that I would spend all my time learning security, but not touching like the software development side of things. I don't want to like to study DSA. So what I did, many trails and failures, many companies came. So I used to approach them individually and ask, do you have internships for security? Do you have full-time roles for security? About 80% of them will say, security is a too of a narrow field. You won't get entry opportunity, blah, blah, blah. But then a startup came and they hired me for their first security role. I was the first security like hire for their startup. So what I'm trying to say is entry level opportunities in cybersecurity are rare because would you trust your banking to a fresh banker or an experienced banker? Why? Fresh bankers also there, no? Even they need opportunities, no? Concept here is banking. It's a very secure thing. You can't play with people's money. Similarly, you can't play with the company's, like the security of a company. So, which is why they don't hire freshers for security. However, if you prove to them that I have the knowledge, I've done the projects, I know what I'm doing, then they'll hire you simply. Hmm? How do you do that? Through all of the things that I just said. Learn the fundamentals, have projects, do certifications. I'll give you access to my blog. Type this. Hmm. This should work. Okay, type tiny.cc/capital RIYAZ. It will take you to a page like this. Replace this INC with R1YAZ. And you'll have access to my blog. Yeah, it works. So this is my blog. Okay. So type tiny.cc/capital RIYAZ. Enter. After that, it will take you to a link that does not work. I've kept it like this because I don't want everyone accessing my blog. So replace this INC over here, the first word, with R1YAZ. Oh, yeah, yes, ma'am. No, this is fine. Hmm? So in this blog, I have a list of all the learning resources that I use to study. Yeah, if you go to this learning resources and then go to career and learning resources for cybersecurity, you have a list of everything that I use to learn security over here. So each of this will take you at least 2 years to study. So for the rest of your life, you have all the learning resources you need. Go into development and then go into security. No, or it might work for other domains. I can't speak for it, but for cybersecurity, what I can tell is if you go directly for a master's, your work experience is still going to be a zero. When you come out, you're still a fresher. Where a bachelor's student stands and the master's student stands is going to be the exact same, except that you maybe know a little bit more than him, but you still don't have that reason for me to hire you, right? Which is why I'm saying after bachelor's, if for cybersecurity specifically, do projects like the one I said. If you can show me that, hey, if take my web application, I know how to secure it, or at least I know certain tools which I can use. For example, now you know Bandit. If I were to interview you and say, hey, my like web application is built on Python, how will you secure it? All you have to do is mention Bandit. I'll be like, okay, this girl knows something about security. Remaining things I can take care. Once you come into the organization, we'll train you. So the difference between an academic setting and a professional setting is in the academic setting, there's a disconnect between the industry, which I think SNU is trying to bridge. I think the syllabus goes through a yearly review or something, right, ma'am? Yeah. So that is really good because you're trying to bridge it with the industry as much as you can, which helps. So do projects. Simply saying, anyone can answer what is DNS. For example, if I ask you what is DNS right now, you know? Yeah, like what is DNS? What is DNS? I know the definition. Exactly. So during interviews, if I ask you this, you can tell me this. But if you have, what would interest me? See, I've taken interviews. What interests me more is the projects that you've done, how you've applied this knowledge. Simple project. If I make a push request to my GitHub, I want an SMS notification. It takes 10 minutes to build. That's it. But it's a very valuable project because it shows that you know SCM, you know cloud. These two concepts are covered in one project. Now, don't come to me and ask how to do it, that you explore, but it's very, very simple, is all I'm trying to say. Explore my blog more. I'll show you. Oh, I haven't filled all this. Okay, I haven't filled my blog yet fully, but so I used in my first year, basically, I was exploring data science, TensorFlow, AI, and all these domains because I don't know what was my domain. So my second year is when I decided that cybersecurity is my domain after taking one online course. So if you go and search in Google for the complete cybersecurity course, Nathan Who's Udemy, you will get this course on Udemy. It's for $400 or something. So skip for biryanis and buy this course. And there are 4 courses like this: volume 1, volume 2, volume 3, volume 4. I did all the volumes. By the time I finished all the volumes, I was in my third year. So do all these volumes. It will teach you a lot about general security. It won't focus on one aspect. It will teach you network security. It will teach you OPSEC, which is operational security, which is also known. So basically, if you see my blog, if you type tiny.cc/Riysz, it takes you to a blog that does not exist. But if you replace that word, it becomes active. This is OPSEC. OPSEC is where you um, you practice security in your daily web browsing. Right. For example, I've used a guest browser. I've not used an actual Chrome browser. So when I close this, everything vanishes. This is OPSEC. All of this is taught in those 4 courses. Um, teach you a lot of other things, like about web application security, about Android security, malwares, reverse engineering. What are the canary tokens? Very interesting concept, canary token. How it works is, I'll have a PDF file on my system which says passwords.pdf. Okay, so if you're a hacker, you would open it, right? If you're a hacker and you have access to my system, what file would you open? Passwords.txt or some random other file. Passwords.pdf because it says passwords.pdf. As soon as you open that PDF, I get an alert on my email that someone has opened the PDF. That's called a canary token. Yeah. So you can use these to set traps in your computer. If at all your computer is exposed and someone opens that file, you will like get an email alert. I have it in my Windows laptop in my home, not on this, but like this whole concept of canary tokens and all I learned from here on. This guy has 4 really good courses. After this, if you see my LinkedIn profile, it will tell you what all the certifications I've done, one by one, in order. So if you want to follow the same line, but I can't guarantee an internship. And learn development, software development without DSA. I hate DSA, absolutely. So that's why I skipped it completely. But what I'm trying to say is, these days for software development, if you don't know lead code, no one's going to hire you. I don't even have a lead code account. Simply saying. So take one domain, be passionate about it, work super hard for it. I used to bunk classes to study security, is what I'm trying to say. If you're going to do something, do it properly, right? And my department gave me full support for that.